The ability to generate cells which produce insulin and can be used therapeutically for treatment of diabetes would be a great breakthrough medically. This patent teaches how to generate such cells that can produce insulin by differentiating bone marrow cells. Now, the title of the patent is bone marrow cell differentiation, and the patent was issued on January 30th, 2007. It's assigned to the University of Florida Research Foundation. What we're going to be talking about is not medical advice or legal advice, and we have no affiliation with the owners of this patent, and we make no claims as to the validity of the statements that we'll be making. The background of the patent is that a lot of different types of stem cells are being considered for treatment of diabetes. Bone marrow stem cells are particularly attractive because they are already in clinical use for hematopoietic transplantation, which is a procedure that's been used for decades. More experimentally, clinical investigation of using bone marrow for myocardial infarction and myocardial regeneration after infarction is occurring today. As well, bone marrow stem cells are being used experimentally in the clinic for induction of angiogenesis. This patent covers ways of making bone marrow, mammalian bone marrow cells, into pancreatic hormone producing cells. So we'll go over some of the claims of the patent. Claim 1 is a method of differentiating a mammalian bone marrow cell into a pancreatic hormone producing cell. The method comprising the steps of providing the bone marrow cell. First, culturing the bone marrow cell in a low glucose serum-free medium comprising about 5.5 millimolar glucose and 1% DMSO for at least 3 days, and then culturing the bone marrow cell in a high glucose medium comprising about 25 millimolar glucose and 10% serum under appropriate conditions and for at least 7 days to promote differentiation of the cell into a pancreatic hormone producing cell. You will notice that this issued claim is a very strong claim in the sense that they're not restricting themselves to specific types of medium. The only restriction is the actual concentrations of glucose and the serum that needs to be added, and here they say about, they don't give specific numbers. So this is an important point. Claim 2 is the method of Claim 1, wherein the bone marrow cell is a rodent cell. Claim 3, the rodent cell is a rat cell. Claim 4, pancreatic hormone producing cell produces insulin. Claim 5 is producing glucagon. Claim 6, somatostatin. Claim 7, pancreatic polypeptide. So here they are just basically describing what the pancreatic hormone producing cells are actually producing. Claim 8 is the method of Claim 1, wherein the high glucose medium comprises DMA-EM and fetal bovine serum. Here they are narrowing in the dependent claim. Now let's just talk quickly about some of the data that was used to support the patent. So essentially the patent's teaching in the specification how to make these IPCs, these insulin producing cells. Bone marrow cells are cultured from the femur and tibias of the rats. They are cultured in DMEM with low glucose and 10% fetal calf serum. After 60 minutes of incubation, the non-adherent cells are collected and they're washed. Then the cells are replated in the serum-free DMEM media at 100,000 cells per centimeter squared in the presence of 1% DMSO for 3 days, and then they are cultured for 7 days in a higher concentration of glucose, and they're plated on 0.3% type 1 collagen. And is described in the patent that these cells at about day 7 and under high glucose conditions, they begin to form small spheroids. After day 10, the number and dimension of the spheroids is increased, and they appear to look like islets. Islet-like clusters is the words that the specification uses. And then the patent describes that the level of glucose in the media has a significant effect on the number of clusters formed. It's saying that high glucose gave approximately 157 clusters per cover slip, but low glucose gave approximately 17. And also, the high glucose produced clusters which were bigger in size compared to the low glucose environment. Now, does this actually work in vivo? So the model used was streptozotocin. It's induced diabetes model. Streptozotocin is a chemical, an antibiotic that kills insulin-producing cells. And as you can see, mice that were on the y-axis is the blood glucose level. Control mice that were only treated with streptozotocin had hyperglycemia. When bone marrow without differentiation was implanted into the mice under the kidney capsule, again, there was hyperglycemia. These insulin-producing cells that they generated in vitro, when these were transplanted under the kidney capsule, there was no hyperglycemia. The glucose levels returned to normal, indicating that maybe these insulin-producing cells are actually functioning in vivo to protect from diabetes. And as we said, these are transplanted under the kidney capsule. So after you transplant them under the kidney capsule and then nephrectomize the mouse, take out the kidney, then the glucose levels, as you can see, begin to rise, indicating that indeed the insulin-producing cells that were transplanted had something to do with protection from hyperglycemia. So in conclusion, this patent is very interesting. It provides a new protocol for generating insulin-producing cells from adult bone marrow stem cells. The claims appear to be generally broad in the sense that they're not restricting themselves only to specific types of media, which makes it more difficult for somebody else to try to circumvent them. And perhaps even most excitingly from a scientific point of view is that the inventors demonstrated in vivo data. Thank you very much.